The absolute value of a number measures its distance away from zero. For that reason, pairs of numbers that are opposite will have the same absolute value as one another. For example, the absolute value of 6 and the absolute value of -6 are equal. They're both 6, because both numbers are 6 units away from 0. Because two different numbers have the same absolute value, when we solve an equation involving absolute values, or in this case, an inequality involving absolute values, along the way, we will always split our equation or inequality from 1 into 2, and then solve each of those pieces separately. To solve an inequality involving an absolute value, our first task is to get the absolute value expression by itself on one side of the inequality, by reversing the order of operations, as is typical for solving an equation or an inequality. Here, we can get the absolute value quantity, which is absolute value of u minus 5 in this inequality, by itself by first adding 7 to both sides of the inequality, giving us 3 times the absolute value of u minus 5 is less than or equal to 18. Now that we've completed all the addition or subtraction that can help us, we next use multiplication or division to get more arithmetic away from the absolute value quantity. We can do that by dividing by 3 on both sides, now isolating the absolute value by itself on the left side of this inequality. In the inequality, absolute value of u minus 5 is less than or equal to 6. Now that the absolute value quantity is by itself on one side of this inequality, the next step is to split the inequality into two separate pieces. The first piece takes away the absolute value symbols but changes nothing else. So our first piece will just be u minus 5 is less than or equal to 6. The second inequality preserves the u minus 5 on the left-hand side, but flips both the sense of the inequality and the sign of the other side. So our second piece is u minus 5 is greater than or equal to -6. Our job will be to solve these two inequalities now separately, but before we do so, we need to know how they're connected together in our final answer, because what we obtain is a compound inequality. Which logical connector is used in that compound inequality depends on whether the original inequality bounded the absolute value from above, in other words, used a less than or equal to sign in front of the absolute value, or whether it was bounded from below, using a greater than or equal to symbol to the right of the absolute value. In the former case, which is what we have in this example, because our absolute value is being set as less than or equal to 6, the logical connector that we need is AND. Now we've obtained a compound inequality, the solution of which will solve our original absolute value inequality problem. Now it's just a matter of solving that compound inequality, solving each of its pieces separately to give us, respectively, u is less than or equal to 11 and u is greater than or equal to -1, sketching each of those pieces separately on a number line, sketching u is less than 11 as a set beginning at 11 and continuing infinitely far to the left, sketching u is greater than or equal to -1 as a piece beginning at -1 and continuing infinitely far to the right, and then, using the AND connector, we will select only those places on the number line where these two sets overlap one another. These two sets overlap one another only in between -1 and 11. And because both -1 and 11 in our original set have closed circles on them, indicating that -1 and 11 are included in this set, our overlap will also include those two numbers. And now we have a sketch on the number line of our final answer. All that remains is to turn that sketch into interval notation by observing that the left-hand endpoint, -1, and the right-hand endpoint, 11, are going to bound our solution. And then, thinking separately about whether each of those numbers is included, we'll complete the interval notation by noting that -1 is in fact included in our final answer because we've used a closed circle on the number line and because the inequality used a greater than or equal to symbol. So a square bracket is appropriate in the interval notation near -1. And also, 11 is included as well in our final answer because of the less than or equal to symbol on its inequality and the closed circle on our sketch. So our final answer is the interval from -1 to 11, which is closed, in other words, uses a square bracket at both ends to include both the number -1 and the number 11 in our final answer. So to solve an absolute value inequality, your task is to transform it into a compound inequality and then use what we know about compound inequalities to solve it. To transform an absolute value equation or inequality into a compound statement, first, get the absolute value quantity by itself by reversing the order of operations. Once the absolute value quantity is by itself, split the equation or inequality into two pieces. One of them, which does nothing but remove the absolute value symbol and leave everything the same, and the other one, which removes the absolute value symbol but flips both the other side of the equation and the sense of the inequality. If the original absolute value was bounded from above using a less than or equal to sign, your compound inequality will use an and to connect the two pieces. If instead the absolute value inequality used a greater than or equal to sign, then the compound inequality will be joined together with an or. Once your compound inequality has been written down, you can solve it and convert your answer into interval notation using what we know from the previous video about solving compound inequalities.